Alright, this is lecture video part 7 of 3.3 hydrocarbons. It's the last one, and we'll be looking at functional groups. The science understanding description is on the third slide. It says organic molecules have a hydrocarbon skeleton. That's nothing new. And can contain functional groups. So that's what we'll be on about. The slide that we'll be looking at is slide 34. We only have 4 or 5 slides to be done. Okay, so functional groups. It's a little recap actually, because there was a definition written somewhere when we were talking about alkane, alkene, alkyne. Those three, they're actually functional groups because, by looking at the functional group definition there again, it's an atom or a group of atoms which give or which is responsible for typical chemical reactions for a molecule. So in another word, if there were a certain functional group attached to it, it might have, say, combustibility. So the chemicals can undergo combustion reaction. So alkane, alkyne, alkene, alcohol, they can all do that. Or things like can be like carboxylic acid. Well, it's an acid. It has got acidic chemical property. It can react. It can donate hydrogen, and it can neutralize any base. So they are the chemical property that it's talking about. Okay. Functional groups, they're determined by patterns of reactivity of homologous series. So each functional group are considered to have its own chemical family, homologous series that is. There's a link for Quizlet in there too. It's been already introduced again, but hopefully you've been spending a bit of time to get you familiarize yourself with the names and structure of each functional group. Next up point there, organic molecules can contain functional groups. That's the big idea. Okay, what sort of functional groups are we talking about? As we already know, okay, alkenes and alkynes, double bond, triple bond, they are both functional groups already. Alcohol group, now I've been using that. This is my ethanol dog. It's got OH group attached to 2 carbon chain. Now, of course, you could make this into just ethane with, sorry, hydrogen missing here, ethane. But by replacing one hydrogen with OH group, you can have an alcohol. So this dog falls under alcohol homologous series, ethanol, that is, this one. This alcohol group is identified with R. The letter R is used for alkyl group. What it's saying is that there is OH group that's considered as a main thing that gives the function or property to this whole thing. OH is attached to some sort of alkyl group, any length of carbon. In this case, 2. It could be 3. Sorry, you can see oxygen. So OH group is 3 carbon chain. Any carbon chain, any length of carbon chain can be considered as just R, alkyl group. So it says R hyphen and OH. So any alcohol group would be having that structure. R being any length of carbon chain and hydroxyl group, OH group attached to. Okay. It's like X in mass, it can be anything. Now, functional groups that I want you to be able to at least recognize this year, not necessarily naming and drawing structures out of name. If you can do it this year, that's good, because in year 12, it's gonna be one of the core knowledge that you need to have and you need to be able to use. So if you spend time enough this year to memorize at least, you know, the group of atoms involved in a functional group and naming of it, what sort of naming they give, it will make your life in year 12 so much easier and less stressful. So if you can spend time to memorize all these, that would be good. So group and naming, that's what we'll be looking at. So, firstly, we've done alkenes and alkyne for double and triple bonds. First one that used in this table is alcohol, which needs to have OH attached to alkyl group, and the group's name itself is hydroxyl group. Hydroxyl group is a name for OH, and it gives the naming of OL, alcohol. So that becomes like ethanol, propanol, and so on. Next one is aldehydes. It has C double bond, and CO double bond and H coming off from the carbon. So if you have got CHO at the end of any carbon chain, you can call that as aldehyde. And carbonyl, always at the end of the chain. Carbonyl is a CO double bond. Ending that any chemical would get is al. So ethanol, propanol, and so on. You can have very similar group with carbonyl group if it was in the middle of a chain. So if you have, say, 3 carbons and the middle one had CO double bond, the carbonyl group, then you would call that as ketone. The acetone is actually a propanone, systematically named. As I just said, propanone, O-N-E, at the end is the name that CO double bond in the middle chain would give. So that's ketone group. Next slide. All right. Similar looking things, a carbonyl group, but with OH group attached to. Now, as collective of that COOH, you call that as carboxylic acid group. Carboxyl is the name of the group, and then it makes any alkyl group into carboxylic acid. As the name says, the H can come off because it's an acid. Benzoic acid is something that you'd have used already. The benzene ring with COOH attached to. Okay, benzoic acid should look like that. And if the hydrogen comes off, then the other side would become an ion. The carboxylic acid can form H plus, hydrogen ion, plus carboxylate anion, carboxylate ion, that is. COO with negative charge there. Okay. For organic compounds, usually charge is drawn with a circle around negative sign. So carboxylate anion should look like COO with negative. Carboxylate ion, so you have to, if you had a carboxylate ion, you have to change the oic acid into O8 ion if you are to name it. So ethanoate ion, propanoate ion, benzoate ion, like so. There are a few more. Now, esters, that's the name of family. The group you'd have is one alkyl group, COO, and then second alkyl group. That's why the group structure says R1 and R2. They could be the same, they could be different. As long as you have COO in the middle of 2 chains, you will have this ester group. Description would be, it's a compound of carboxylic acid and alcohol. So carboxylic acid and alcohol join together to make ethanol, ester. Naming, we'll probably practice that in year 12 more like. R2 with YL at the end, and R1 with O8, because there's a combination of carboxylic acid and alcohol. Alcohol first and then acid afterwards. Next one down is amines. So amine group needs to have NH bond somewhere. Yeah, so it's a bit like attaching ammonia to alkyl group. Okay, amino group it's called. Like amino acid, it actually has something to do with it. Okay, if you have got methane group attached to amine, methanamine, it's gonna be something like that. Amides can have primary, secondary, and tertiary, but in here it's only showing a primary amide. Now in amide, you have to have CO double bonds, so the carbonyl group, and NH attached to directly, CO and NH, okay? That can extend the link, and you can make polyamide or peptide, which is usually known as protein. The amide is gonna be the name that's given to amide group. That's a shorthand for all the alkyl groups that's shown. Sorry, the functional group that's shown with alkyl group attached to. So hydroxyl group would be, alcohol group would be ROH, aldehyde group would be RCHO, ketone would be RCO R dash, carboxyl group RCOH, carboxylate ion, well, and so on. You can read that. Now, if you didn't take note of the rest of the three tables beforehand, you can just copy this one. Make sure you can recognize the name of the group and shape of each functional group. All right, I think the next slide is just about, doing questions and what other related information are there. We'll watch these videos in class anyway. So that's the end of 3.3 hydrocarbons. All right, I'll see you in class.